Okay, we have 12 more problems, 4 on this page and then 4 on another page and 4 more on the last page. Same thing, we're going to multiply and then we're going to simplify our radicals in here. So in the first one we have radical 6 times radical 5. Well, when I combine them, it's radical 30. I asked myself, hey, can we simplify radical 30 using the factors that are perfect squares? And the answer is no. There are no factors that are perfect squares of 30, so that's the final answer. The next one looks really intimidating with those fractions, but if you notice, remember, if we're multiplying these numbers together, notice the 5s are the same on the upstairs and the downstairs, so they actually cancel, and more stuff cancels. Notice 3 goes into 27 9 times. So when I multiply straight across, this is radical 1 all over, the 9 is left in the denominator. But I'm still not done, because if you think about it, this is the same thing as radical 1 all over radical 9, so that turns into 1/3. Alright, let's try the next one here. When I combine these two radicals, this turns into what? This turns into radical 28, x to the first times x to the third, that's x to the fourth. And I have y to the first times y to the first, that's y squared. So when I try simplifying this, radical 28, I notice 4 is a factor of 28. So that's going to be 2 radical 7, because 4 times 7 is 28, but the radical 4 got simplified to 2. And then how many x's are left? Well, that's going to be x squared that comes out of the radical, and then just one copy of y. So that's how we simplify that one right there. And the next one in here, we have radical ab times radical b squared c. So altogether I have a b cubed c. So when I simplify this, well, it looks like the a is going to be left in jail, the radical sign I should say. B cubed, one set of b squared come out to become a b, and then there's one b left over in the radical sign, and then the c stays underneath the radical sign as well. So that's how we simplify that one. Let's try another 4. Well, same idea here. Radical 7 times radical 10 is radical 70, and I'm always thinking about this famous list of numbers. Are there any factors of 70 that are on this list? And the answer is no, so that one's good to go. Look at this one again. Notice these 5s cancel, and I bet you 6 goes into 216 evenly. If I whip my calculator out here, and it does. This is 36. So this turns into radical 1 over 36. And if you think about that, that is exactly 1/6. The next one in here is going to be the square root of 50 x squared y cubed. That's going to turn into 5 radical 2, and then the x comes out, and then a y comes out, but there's a y left underneath the radical. All right, and then the last one in here, very similar to the one we just did a moment ago. That's going to be a b squared c squared. So that final answer is going to be b c radical a. Think about that. Pause that if it makes sense. How the b and the c came outside the radical, and then the radical a stayed underneath the radical. All right, we have 4 more problems, very similar to the last 4. So in this one right here, it looks like we have radical 7y times radical 7y. Hopefully you know where this is going. This is 49y squared. And what is that? Well, that's 7y. So I'll look at the next one. We got radical 5 times radical 10. And it looks like we just did that a moment ago. That's radical 50. If I did break it down for you, that's radical 25 times radical 2. That turns into 5 radical 2. Notice in this problem, notice we actually combine them together, and then we break them apart to simplify them. That's kind of interesting. It's kind of counterintuitive to kind of put stuff together and then break it apart. But how we break it apart is we're using this one as a perfect square. There are no perfect squares in 5 and 10, so that's why we mush them together to form 50, and then 50 turns into radical 25 times radical 2, giving us 5 radical 2. And the last one here, if I start to combine these as 18 times 12, I'm going to get a number that's pretty large, as 216. Okay, let me just stick with the large number, and I'm going to combine them into 1. So that's going to be 216, and then how many a's do we have? We have a to the 6th. Looks like we have b to the 4th. All right, so now, radical 216. I don't know my 216 times tables, but I do know my perfect squares. And I do have a calculator in my hand, and when I use my calculator, I'm thinking about what are the factors of 216 that are on this list in here. So I'm just multiplying or dividing some numbers in here, and it turns out that radical 36 times radical 6, that's 216. So what happens here is the radical 6 turns into a 6, and the radical 6 stays in the radical sign. And then since I have a to the 6th, this turns into a cubed. If I have b to the 4th, that turns into b squared. And that is the answer to that last one. Again, that's another set of intense multiplying of radicals and then simplifying radicals. Make sure you get plenty of practice through the homework. All right? See you on the next one.